start, madam.
Yes, sir. Yes, sir.
Good morning, participants. Today we are having an eminent person, Mr.K.Vijay Kumar, Joint Director, Center for Development of Advanced Computing. He has over 15 years of experience in big data technologies, deployment and management. So I welcome you, sir, for this session on data science path to specialization. Sir, over to you, sir.
Thank you, sir. Thank you. Let me share the screen. I hope the screen is visible.
Yes, sir. Yes, sir. Your screen is visible, sir. You can continue.
Yeah. So in today's session, I plan to give data science a path to specialization. Then I thought, why not make it a path to specialization as a roadmap to data science specialization? So that was what I planned for. And in this session, I would like to demystify data science, the role of data scientist and all those stuff. So to move ahead. To see, we would like to give a profile on the data science. In fact, like when I say data science as a topic, what and all can be done. So what is data science? Why the data science is required? What are the tools required to harness the data science? And what are the applications around data science? And what is the capability? Rather than capability, I will say ability. So what is the ability of data science in solving the problems? That will be more accurate. And when you are mature enough to handle this data science, then what kind of job or role you will fit in. So these things we are just going to see. So let's move on to what is data science. When I say data science, it is a robust field that best fits people who have a knack or zeal for experimentation and problem solving. So when I say so, it's a multidisciplinary field that applies to domain knowledge, mathematics and statistics, and of course, soft programming skills. When I say soft programming, yes, computer science, I can say so. So when data science applies to more like collection, preparation, analysis, visualization, management, and preservation of the data, both structured and unstructured. So when I say domain knowledge, what is domain knowledge? When I say domain knowledge, it is like medical domain, education domain, civil engineering domain, like that, automobile domain. So each thing is a separate field where it has its own workflow, input, output, data getting generated, and all those stuff. Now, how are we going to leverage this domain knowledge using data science? That is what the entire crux is. So here we require the complements of mathematics and statistics. So when I apply mathematics and statistics with domain knowledge, it evolves to traditional research. Okay. So, but a guy with a mathematics and statistics and also having a computer science background with the programming skills, then he will of course apply machine learning and try to apply on a particular objective. Okay, so that's where he's ending with the machine learning. But now with when I say programming skills with domain knowledge, he is limited only to as a data engineer. That is where he's leveraging the domain expertise again there. Now, the confluence of this domain knowledge, mathematics and statistics, and programming skills together form the data science. So this is where people who are venturing into it, we should have the zeal for experimentation and problem solving. So to make it more lucrative, I will say that the future belongs to company and people that turn data into products. So here I have again focused data. Out of data science, data is our prime thing. So we can understand data science as a field that deals with data processing, analysis, and extraction of insights from data using various statistical methods and computer algorithms. This is in crisp I have conveyed you what is data science. So let's move on. So I have stressed the word data. So when I stress the word data, which is required to be converted into product. So that is where the future is. So what I conveyed is future belongs to company and people that turn data into products. Why? Because data is now the new fuel. It requires to be redefined in terms of culture, redefined in terms of operating boundaries, sharing the data, and how better we can collaborate with the other entities in terms of data sharing and building business models. So this is where the data is. Because when I say data is the new fuel, it is because the ubiquitous of internet. The evolving of Web 2.0. That's a revolution, in fact, in the technology now. Like Web 2.0 has come, social media applications have come, cloud computing, software as a service, okay, then SaaS applications, then IoT, Internet of Things, okay, then blockchain, many more, quantum computing. So all these are what? They are all generating data. Finally, your ultimatum is data. So data is our new fuel. How are we going to leverage it? So when I say it needs to be redefined, we need to think on the aspect like now I have the data. How do I use it? So what are the influentials of getting the data because of whatever I've conveyed you now, the like sensors, IoT things, cloud computing, all those stuff. Okay. Now we have the data. That is like we have enough information. Now we need to search for the problems because the solution is already inside the data. I hope all of you agree with me. The data is getting generated out of our day-to-day transaction or communication. Now the solution is embedded in it. We need to identify the problem. That is what here I have conveyed. Fall in love with the problem, not with the solution. Once we identify the problem, we are going to provide the solution. So how are we going to provide the solution? To provide the solution, we require data science. Data science is the roadmap for us to take to that solution. That is why our center of our focus is read my thought, predict my behavior. Okay, to read your thought, I have to assume what you might be thinking. So that what is what the problem I am defining. Based on that problem, I will predict the what you will be thinking. So that is what here is. Read my thought, predict my behavior. Then comes data science hierarchy of needs. So this slide actually conveys like now we have been talking about the data as a fuel. When will the data become an information? So basically you need to collect. Okay. Once you are able to collect the data which is of interest to the organization, the data which is required. Okay. that data you have collected and you are storing it. Once you are able to store the data, then you should be able to index the data. Once you are able to index the data, that means you are able to link the data and share the data, search the data. Once you are able to search the data, that means you can, of course, share the data to other person and use the data. That's where information comes into. So that's what they are converting the data into information. That is what is called transformation. So here you require specialized tools like ETL, like extract, transform, load. Okay. So for that, there is a kind of a heuristics applied on that. Okay, where this is called pre-processing of the data. So you require, so the lowermost is like you have the data which you require to collect it. That is called instrumentation, logging, sensor data, the data generated out of machines. All these are collected and you are storing it in a reliable source, and there is a flow in the data and in infrastructure. It is in the pipeline, and you're using specialized technique like ETL. So structured and unstructured data are that you are converting everything into a form where you will be easily able to read it. That's where cleansing, anomaly detection, and preparing it to a form, annotating and seeking the data out of it. Once you are able to label the data and aggregate the data, then you are applying all your data science techniques on that. That's where machine learning, deep learning, and AI and all those stuff. So if you see this pyramid, the top level is AI. Okay. So our entire concept on this session is the roadmap to specialization. That specialization means that at every level you are maturing yourself to the next. That is where artificial intelligence comes into. So the ultimatum is bringing some AI, because we are as a human are lazy in nature. We want everything to be available, well prepared in our table. If it is a dish is readily available to eat, we will directly start go for having it rather than go and again prepare, buy the grocery and all those stuff, right? I hope you agree with me what I'm trying to convey. Actually, here it is like the AI is our objective. Data science is taking us towards AI, where we will be able to generate solutions which are which a human will be able to do in the best way. Okay, so that is the data science hierarchy of needs conveys. Okay. On this aspect, we are next moving towards how better we can harness this data science or harness this data using this data science. So we require some specialized tools. So when we say data science and we are defining the data science, that there should be some tools to reach and handle that data, right? So this is where I have listed out some of the tools, which is not exhaustive. I just want to convey in this short 1 hour session what and all I can convey on some little bit on few prevalent tools to say with. So when I say data science tool, R language is very much useful, where it is specifically tailored for statistical computing. So it is widely used for data analysis, statistical modeling, time series forecasting, clustering. So it also possesses features of an object-oriented programming language. It is an interpreter-based language. Okay, so it is widely used across multiple industries. Now you can see next is Python. Python is an interpreter based on high-level programming language. It is mostly used for software development, in particular for data science, I will say. So it has gained popularity due to its ease of use and code readability. As a result, NLP, data analysis, computer vision, these are all very rich libraries are available in Python. For example, Matplotlib, NumPy, SciPy, some deep learning libraries like TensorFlow, PyTorch, Keras. Okay, so these are why I'm saying so is one aspect is statistics, mathematics and statistics. But applying those mathematics and statistics, you require ready-made libraries to apply. So that those libraries are very rich in Python. Of course, R is also equally good, but the both are equally good. I need not compare to that, but I'm more comfortable in Python, and I would just recommend Python for when you go for big data and all those stuff, because we are not going to limit ourselves only to the traditional programming and all those stuff. Next comes very much required one is SQL. SQL is nothing but the structured query language. Okay, so when I say structured query language, it is very much required for querying the data stored in the database. So I think we have almost excelled ourselves in handling structured databases. So here what is happening is we are fetching the data which are already designed in such a way that is like schemas, table, attributes and all those stuff. So we can easily fetch the data. So it's like confirmatory data analytics. Okay. So, but it has its own limitation. But when we are applying for unstructured text and all, there you can of course go for NoSQL databases like MongoDB, Cassandra, HBase, okay, then Graph database. These are all NoSQL databases where they can handle petabytes of data. And here we are focusing everything on data. So when I say data, it will scale in terms of volume, variety, and velocity. Okay, so voluminous data in terms of it is in the metrics of petabytes, exabytes, like that. Then variety, you are not limited only to structured database. You will also have unstructured and semi-structured data, that is textual data, then audio, video data. So you're required to handle all these type of data. So there, NoSQL database is a very good tool to handle. So you can build expertise on that. Next comes Hadoop. Yeah, Hadoop is, as I conveyed you, it is now, as I conveyed you, the three forms, no, like volume, velocity, variety. This kind of thing, you require a specialized tool where you can have distributed computing. So this Hadoop is nothing but a distributed framework which has its own ecosystem of tools to handle and manage the data. Okay, so when I say manage the data, you can store the data, you can share the data, you can keep the data in a resilient manner. Okay, that is very important, no? After that, you require computation, that is processing of the data, where you require distributed processing. If you use a traditional serialized method, it will take months to process petabytes of data. Okay, so there you require specialized tool like Hadoop framework. Okay, so there you require distributed processing framework like MapReduce. Now, like Spark and all has come in memory applications that also does MapReduce, but in background you need not think about the how to write the logic in terms of mapper and reducer and all those stuff. So that kind of abstractions have come up now. So we are maturing at every stage and moving ahead. So I'll take next level. Now Hadoop is a very important part in your data, applying your data science to a higher level. Okay. Then comes Tableau. Tableau kind of an application. When you say it's purely a data visualization software, in which provides graphical analysis of data. It allows its users to create interactive visualization and dashboards. This makes Tableau an ideal choice for various trends and insights of data in the form of interactable charts such as tree maps, histograms, box plots, like various other things like that. So important feature of Tableau, if I say, it is its ability to connect with spreadsheets, RDBMS, like various databases like Postgres, MySQL, Oracle, and all those stuff, and cloud platforms. So it is a very good visualization tool which you require to learn when you are applying data science. And yeah, Veka, I think all of you might be very much aware of. It is in fact, a specialized tool for data scientists, I would say, which is very much familiar with machine learning, okay, data mining, and all those stuff. So I'm just not touching the other tools. It is as we have a very limited time, I just want to convey or stress the fact on roadmap towards how we can move in data science specialization. So some statistics on this for the data scientist is that the roles of data scientists has grown by 650% since 2012. That means you imagine the kind of need now for data sciences. In fact, 11.5 million jobs will be created by 2020. This is what statistics in the US Bureau of Labor Statistics is conveying. So this is what I would like to stress on the growing demand for data science. So what you require in this roadmap to specialization is some soft skills. Those soft skills are nothing but the languages or tools for data science which I have conveyed you. Then you require some basic knowledge on mathematics and statistics. You require some specialization on data visualization. Unless you are able to visualize what you have inferred, it will not reach the higher authorities, because the higher authorities want to know on the problem that you will be conveying through visualization. So that specialized tools are like D3.js, Matplotlib, Seaborn, Tableau, all those stuff. Okay. And of course, big data, as I conveyed you, for distributed processing and distributed computing, right? Where Spark, NoSQL database, Apache Nifi, Kafka, they are all some specialized ecosystem tools of Hadoop for online streaming and all. Next, when we say data science, of course, machine learning and all quickly comes inside, where you will be applying specialized algorithms like regression, classification, clustering, deep learning, natural language processing, and all those stuff. So yeah, so I'm just including these things like web scraping, data analytics, these all into the roadmap to specialization. So I was just surfing the net, I could see, okay, this thing could be much more reaching to the audience, like what and where each role will require the skill set. So as a data analyst, he should be well versed in programming tools and visualization. And as a data engineer, machine learning is very much important. So he needs to know more on data intuition, statistics, ML, then yeah, that is where multivariate calculus and linear algebra and all this stuff. Okay. So as such, if you are maturing to the data scientist, because it is the highest job, which is highly paid job. If you see, he is almost well versed in right from machine learning, data wrangling, statistics, visualization, and programming tools. So when I say data science, yes, it of course applies to data analytics as well. So in that, in my roadmap, you would have seen that. So when I say data analytics, you have 4 segregations on that. One is descriptive analytics, other is diagnostic analytics, then predictive analytics, and then prescriptive analytics. So descriptive analytics, when I say it, is just conveys what happened. It just records the incident or information what has to be conveyed, okay, as a text, a para, or so it is nothing but what happened. Okay, you are not going anything more than that. So why did it happen? Yes, it is the diagnostics on that description. Like it is just coming out with facts and figures based on the description. So nothing more added to it. There is no algorithm specifically to predict or anything. But when what will happen will come on predictive analytics. So we are going to apply some kind of a machine learning on the pattern of the data. And that pattern of data should be will depend on the quality of the data, will depend on the amount of the data, and of course will depend on how you the quality of the algorithm, the best fit algorithm which you are going to apply on it and train the data. Okay, so and when you train the data, you can of course predict the and bring the accuracy. That is where predictive analytics is. And prescriptive analytics is something which is what should I do? That means something proactive. Okay, it is the system itself is learning on its own and acting on its own. If it is there is a error, what should I do for that error? Immediately it will correct that error and learn itself and work on that fashion. So like a very good example will be driverless car. Okay, so this all comes under the 2 broad categories, not or let me convey it as in machine learning you have various categories like supervised, unsupervised, semi-supervised, and reinforcement. So when I say supervised, yeah, you have classification. Okay, everything is labeled and you work on that part. Okay, so this is where you work on. But semi-supervised is fall somewhere in between supervised and unsupervised. This is where both labeled and unlabeled, because unsupervised is totally unlabeled, where you require to identify the hidden structure, I will say that. So you require to draw inferences from the data sets to describe the hidden structure from unlabeled data. Okay. So next comes the reinforcement. I'm just trying to, in my previous slide, I just wanted, we have been conveying this data analytics. These are all coming under this, whatever I'm trying to convey, that is supervised, unsupervised, semi-supervised, and reinforced machine learning. Okay, so that reinforcement is something like you are making the machine and the software agents to automatically determine based on the ideal behavior. Just like how you train or tame the dog, Like once you are training the dog is doing it in the right way, you immediately reward that dog with a biscuit. The same manner, the machine is learning or getting uh, the feedback on every reward. The machine is reinforced to learn that particular uh, methodology. Okay, so that is where the reinforcement is like for gaming and all. You will be using this kind of a thing. So now, as I was conveying you on data analytics, let me just have a small brief on the innovations through data analytics. So here you can apply search. There are different applications. In my first slide, you would have seen what are the applications revolving around the data science. So everything is gelling out to data analytics, where you will be applying different innovations. So one such is like search at scale, multimedia content, sentiment analysis, enriching and contextualizing, exploratory analytics, embedded analytics. Let's have a quick look on that. Um, when I say search at scale, you would have seen the Google search and all. When you type ABS, automatically auto spelling correction comes, then fuzzy matching, then type ahead query. These are all nothing but applications of search at scale, which itself has become a technology. You are applying natural language processing here, semantic analysis, and all. I'm just giving you a cursory overview on different innovations of the applications. We will have a small discussion on that AI applications as well when we are moving ahead. So next comes multimedia content like images, videos, audios. So when you are taking a photo or image, uh, what happens? The system has to learn what that photo or image, when that photo was taken, at what occasion that image was taken, where that image was taken. So these are all nothing but the metadata informations. So this, you are handling a unstructured text, so you are applying some specialized techniques in data science to handle it. So in fact, you will be converting these things into a format where system can understand and learn it. Okay, so you have to bring it to the data frames, and there you will be applying it. So these are all from users perspective and how the system learns. So you require to change or convert it into metadata. Once the metadata information is start storing the data, it can easily handles multimedia content. Then comes sentiment analysis. Yeah, you are handling unstructured text where you are discovering the sentiments. It's a polarity, identifying the opinion mining like yes, no, true, false, likes or dislikes, uh, how uh, how much rating you are giving for a particular movie. These kind of things are a good example for sentiment analysis. A very good use case is brand analysis, I will say. Next, to move forward, you have enriching and contextualizing. So where you are applying ETL to enrich and contextualize your repository. In fact, as I conveyed somewhere, like social media applications. So social media applications uh, play a role in diversifying the business. So as a vendor, if I want to market my product, I'll be looking at the sentiments of the various customers. And if a negative feedback comes, I will try to enrich my repository. So I have my own database where I have the specification, information about that particular product. So I will take that negative sentiment and enrich it in my repository or database, and dedicate an R&D team to work on that negative sentiment and build my market share and sustain myself in the market. Okay, so this is where we can use data science for. Okay. Next, you have exploratory analytics and operational analytics. So exploratory analytics is you're discovering the data from the unknown pattern. You're applying machine learning and all those stuff. Here, the data science scientist does not will be defining a problem, but ending into some other problem. So that is where he's keeping on exploring the data. And operational analytics is like more embedded analytics, I would say, like machine-to-machine interaction data in real time. The system itself will correct itself and act accordingly. So, for example, in heat treatment, a particular product has to be heated for a specific amount of time. In that case, if it is heated even 1 minute more, it becomes brittle. So the cutoff from that particular after that particular time is an operational analytics. In nearer time, it will do that. So overall, whatever we have conveyed, it is everything a roadmap. Now, as a whole, if we have to give it, we require a kind of a flow. So this is what I was conveying you. Like the data is available in different forms. You are doing ETL, transforming the data into an information where you can collate and search the data, apply data science algorithm on that. So you require specialized visualization tools for reporting and dashboarding to infer the insights out of the data science application. Okay, so various applications, if you see in here, like analytics in railways, if you see, yes, they have done many things. In fact, they have moved 360-degree view of the customer data. Why? They can, for promotional aspect, to improve the business. So they can understand the consumer behavior. Why? Even they are predicting whether how much chances are there for your reservation, whether will it be booked 85%, it will be chances are there, or 90% or 100%. So these are all using the data science techniques only. Next comes outreach work, and how you can do that. So you have one small example is like CDR analytics. Okay, so I hope all of you have at this stage are having mobile. So CDR analysis is nothing but that called data record analytics. So it contains some data in contiguous bytes, like characters. Okay, like caller ID, and called ID. So this is not a SIM number. Okay, then tower ID, that which tower the person has called from. So these are all nothing but information we can draw insights from. Okay, to solve many informations. Just like we have done certain things for solving crime, for solving the crime and all, like how you can identify the relationship between the followers and who is the follower and who is the leader. Those kinds of informations you can get from CDR data. and you can target individual promotional advertisements to particular individual. Then you can, once that individual churns, the entire his group will churn. This is a very easy way of I have what we can do in a very good example for data science application, I would say. Then we can apply data analytics to manage food shortages like logistics, optimization, or supply chain management, all those stuff we can do. Okay. We can improve the crop productivity. Then comes healthcare. Yeah, healthcare application. Yes, we can move from reactive to proactive. Okay. Like now all the smart gadgets are available which are capable of generating data. So this data is very much tracked with the patients, and the doctors are able to monitor that data and give a proactive decision on the healthcare. Why? You can, very good example now, what we are prevailing example is COVID-19 itself. You can take. Now today, COVID-19 being a pandemic disease, you can see the spread now. It is now getting exponential. What is the reason? So there are various reasons which now with the data points, whatever we could collect, we could, many have come up with many kind of insights, like what might be the reason and how we can curtail this pandemic spread. Okay, so how we can do that? So we can make statistical inferences out of the past data right from January. So at some point they told that due to that some gathering in Delhi, the entire spread had come. But here also we were keeping quiet at some point, and where a particular hotspot was where the entire market is concentrating, okay, where people were getting mingled. That is now that has become the main criteria, even though the nation had declared lockdown and various other things. But there were many, what to say, measures taken. Those measures were all can also be taken as a data point, say lockdowns. So that lockdown, to what extent the curfew was, the entire 24 hours curfew, or 12 hours curfew, or 18 hours curfew, and slowly in lockdown 1, lockdown 2, lockdown 3, it was kept on relaxing, and now what are we facing? The Whether the spread has come down or whether it has increased. So these and all are purely using data science techniques, statistical methodology, which we have applied and we are able to infer. So some AI applications, I would like to touch into. So when I say AI are broadly into four, like reactive machine. Reactive machines, and I say it does not store memories or learnings from the past experiences. They simply react to the surroundings and choose the most optimal solutions among available alternatives. Okay. Some good example for reactive machines, if you say, it's like chess playing supercomputer. Okay. It has in fact defeated the international grandmaster here. So it is purely an AI application. The other part of AI, when I say of application, you can have limited memory. So limited memory, it lasts for a short period of time. Can use experiences occurred in recent past to inform future decisions. So a very good example for this is self-driven car stores that speed the pattern of changing lanes, okay, and navigates on the basis of this data. Okay, so these are all now. Uh, I'm giving you the segregations on the artificial input. Then comes the theory of mind. Theory of mind, and I say it can simulate on human emotions, beliefs, and desires. Um, you can derive from the behavior on that how a human interacts or thinks about. So the actually we are working on it like robots and all. Okay, robots for hotels and all. You can predict the demands of the people who intend to stay in the hotel. So they are all AI application. Then next comes self-awareness. We are still working on this self-awareness kind of a part in AI. So I will just give a uh, I'll touch on various applications in listed here, like automobiles, business, education, finance. And I say automobiles, as I already conveyed you, driverless car is a very good example for AI application. It has incorporated applying brakes, changing lanes, navigation. So what happens is every time the system is learning, artificial intelligence is learning. So your data, your science has moved from basic data collation, collection, transformation, and then machine learning, then deep learning, and now you have moved to an application where you are maneuvering an automobile uh, to drive without a driver. Okay, so that is the as I told you, human is a lazy by nature is lazy. So he wants to move from one place to other to buy a car without a driver. So that he is applying an application on automobiles in such a way. So that's that. Next comes AI for business. And I say AI for business, a firm can use AI to identify the weaknesses and strengths. When I say weaknesses and strengths, it applies to reduce on finance, production related, then customer relationship management. Okay, so it will actually apply on automating tasks that turn to reduce lot of manpower. Okay. Uh, McDonald has done is one such example where he has used AI, and then we can give AI for education. When I say AI for education, it can deliver better learning experience by adjusting learning as per the needs to each student based on the capability or ability of the student. Okay, the AI will provide the it's course level, yeah. If to what level that student is comfortable based on his learning. Okay, so it can also automate the grading systems and provide additional support to the students as and when required. Yes, you can to next apply AI on in finance, where you can collect personal data and provide advice and suggestions. Uh, say for example, CIBIL rating. If a person is very good in CIBIL, there is an individual promotion being targeted to his mobile, conveying that we are ready to give loan to you. immediate within 5 minutes your loan will be approved. They will not a bank will not be ready to approve the loan to any person within 5 minutes. He will see the history, he will see the pattern of his transaction, he will see his credibility. So these and all are AI applications where it gives recommendations. Okay, then comes AI in gaming. When I say AI in gaming, it generates alternatives in video games on the basis of decision we take in the game, like pathfinding. Okay, then Tom Clancy's Splinter Cell. They are all some AI-based programs. Of course, AI plays a very vital role in government, uh, like in making suitable policies and services. Uh, uh, Policies and services to various demographic people, I will say, suitable to different demographic. Okay, the policy might be different for Tamil Nadu. The policy might be different for people in Himachal Pradesh because they are in a hilly station. Okay. So the services, what has to be reached to the pupil, needy pupil. So so building policy is a very good example in AI, where AI application can help on different parameters. Then it can also counter natural disasters, road accidents. Okay. In fact, a very good example like disaster management and all. And of course, um, it can reduce the cost and errors and save uh, some mundane task. I would say that will be more better. Okay. And of course, I have conveyed you about healthcare. So I need not continue with healthcare. Manufacturing, yeah, to enhance the production and quantity, in terms of quantity and quality, we can um, we can bring betterment. We can do forecasting for future demand and supply, and come up with a very good solution for logistics as well to cater the demand and supply of the market. I hope I have addressed and I leave the dice to the audience for questions. Thank you.
Sir. Thank you very much for your session, sir. Very informative with respect to the data science, starting from fundamentals, what is data science is, why we need data science, tools, applications, what is the job role now which is suited for data scientists. Then hierarchy of needs, data science tools, growing demand of data scientists, roadmap to specialization, skill set specialization, types of data analytics, innovations through data analytics and the different AI applications with respect to data analytics. So I think most of the audience would have been benefited with your information regarding this data science and what are all the skill set required. That is the main thing which people are not aware much. So now with your this session, they might have got some information with respect to these areas. So thank you very much, sir, for your session. Madam? Madam? 1 minute, sir.
Yeah.
தேங்க்யூ அதுவும் கேட்கல. இருங்க நான் மறுபடியும் சொல்றேன். நீங்களும் அன்மியூட் பண்ணுங்க, கேக்குதான்னு சொல்லுங்க.
Hello.
Hello, sir, கேக்குதா?
Yeah, madam.
Sir, Vijay Kumar, sir, thank you so much, sir.
Thank you.
Thank you for spending so much of time during this COVID period, sir. Thank you, sir. Thank you so much.
Thank you. Thank you.
Thank you, sir.